scale of 1 to 5, trying to write the equation from a graph. Or if I gave you multiple choices and you had the equation without using Desmos, how are you feeling about those problems? So 1 to 5. You put any number between those. 2 or 3, okay? 3. 3's not bad. All right, 3. Okay, so at that rate, because it's live class and this is what we're here for, let me do these last couple, or these couple that I have. So remember that what are the 2 things we need to write the equation of a line? Yep, slope and y-intercept. Am I okay on lag, guys, so far? That you can tell? Okay, awesome. So the slope is your rise over run. Your y-intercept is where it crosses the y-axis. So that would be here. So -3. Slope, we're going to count up. 1, 2. There's another good point. And we'll go check for more good points first. There we go. Over 1, up 2 over 1, up 2 over 1. So it's a positive 2 over 1. The y values are increasing as the x values are increasing, or it's going up reading from left to right. So that means we know it's a positive. So our slope is 2 over 1, where you will probably more times than not see that as just 2. But rise over run, it's 2 over 1. And then your equation at that point would be y equals 2x minus 3 for this line. Now, this one is fun. So it depends on how your middle school teacher taught you. I love this. A student actually taught it to me back when I taught at Scotland County. So Hoy Vux, and it seems really silly, but it keeps a lot of information in one little acronym. So Hoy Vux. So horizontal line, which means it's going this way, because that's what horizontal is, has a 0 slope with a y equals equation. So 0 slope, y equals equation, horizontal line. Vertical line, which is the V, which is pointing down, so up and down, in case vertical doesn't define itself, has an undefined slope and an x equals equation. Because 0 slope and undefined slope is very easy to get confused. So horizontal line is 0 slope. So Hoy Vux is hugely helpful. If you want, I would write that down on a Post-it note and keep it somewhere so it like drills itself into your brain. This is a horizontal line. So that means that the slope is 0. And we know it's going to be a y equals. And the reason it's a y equals is because no matter what the x value is, wherever we go on this graph for x, the y output is going to stay the same. So that's going to be a -2. So y equals -2. For all values of x is why that's a y equals equation. So horizontal, 0 slope, y equals. Vertical, undefined slope, x equals. All right. How about 1 to 5? How do we feel about converting from standard to slope-intercept form? So isolating that y. And I'm going to go try to get rid of my email real quick. That's why I'm getting all these notifications. Oh, that's not good. It's open. Never mind. We'll leave it alone. So 1 to 5, isolating y. So from standard form where x and y are on one side, getting it into slope-intercept form. How do you feel? All right. 2.5. I like it. Okay, so great divide. We know we want to isolate y. So because we're going to isolate the y, what's on that left side with the y that needs to move, that's outside that box? Yes. And that's a positive 9x. So how are we going to get rid of it? Negative 9x. Good. Sorry for all this switching to screens, guys. So minus 9x, minus 9x. So I end up with -7y equals, and I'm just going to leave it in the order that I'm writing it at the moment, like I said last time, and then we'll switch it around. Looking at y, is y by itself yet? And then what's attached to y and how would we move it? What operation would you use to get rid of that 7y? We'll get rid of the 7. We're not trying to get rid of the y. Yes, so we're going to divide by -7. We're going to do it to each one because remember we want a rise over run and then we want a y-intercept. Y-intercepts are better as whole numbers or decimals because if you're looking on your y-axis, some of us have a hard time finding a decimal on the, a fraction on the y-axis. So these 7s go away. Y equals, what's 42 divided by 7? A -7. Mine's a little hard to read. 42 divided by a -7. Going to give me a -6. -9 over -7 is going to give me positive because it's a negative and a negative. And 9 and 7 are both prime, so they're not going to get any nicer and neater. So it's going to rise 9 and run 7. Your y-intercept is going to be a -6. So if you had to go graph this on a piece of paper or on a piece of graph paper, you would start at -6 on your y-axis, then you would count up 9 and over 7. This line should be increasing, reading left to right, because that's a positive 9 over 7 slope. All right, great divide. Who needs to move and how am I going to move him? Yep. 11x is going to move. How are we going to move it? Add, subtract, multiply, or divide. Yep, we're going to subtract it because he's positive. So now I have these guys gone. Negative y, be careful. That's a big place where a lot of people mess up is we lose that negative. Sometimes I recommend putting a 1 in front of things like that. So then we seem to do a better job if there's a number there versus just a loose negative sign. So this y is still not by itself. Just like that -7y, this is at -1. So we're going to divide everything by -1. And y equals a -7, negative and a negative again, gives me a positive 11x. So we can rewrite it in order if you want. It's fine this way as well because you should know that the coefficient of x is our slope and then the constant, so the number without a variable, is your y-intercept. So as we said on the last one, we're going to go to that -7 on our y-axis, start, so we're going to draw a dot. Then this 11 over 1x, because all whole numbers have an imaginary 1 over them, we're going to go up 11 and to the right 1 as we're graphing that line. And again, it's positive slope, so it's going to be a positive line. So increasing to the right. As x values increase, the y values are going to increase as well. All right, so number 5 and number 6. Hoy bucks is what we want to think of these guys. So thinking of Hoy bucks, so horizontal 0 slope, y equals vertical undefined slope, x equals. If I have an undefined slope in number 5, I know it's going to be an x equals or a y equals. Yeah, exactly. So it is going to be an x equals because that's undefined, and that's where we found our u here. So we know it's going to be an x equals. Now, if you look at this coordinate, we could plug all this in, except that undefined is not a number, so you can't really solve with it. So looking at this coordinate, the only x value I have is 1. 1. Just to call out as well, because as soon as you can get it into your brain, as soon as you see a y equals 0, this is always your x-intercept. When y is 0, that is the x-intercept. When x is 0, it's the y-intercept. Remember, it's x, y in the coordinate, so x is alphabetically before y. So the first number in a coordinate is your x, and y is your second coordinate. Now, how about when the slope is 0? Is that going to be a y equals or an x equals? Slope is 0. Y equals or x equals? Good. So hoi, there's our 0, y equals. So y equals. Now this one you could, if you wanted to do all the math, plug this in the y equals mx plus b, because we have our x and our y value. So this is our x. This is our, whoops, not open, sorry, y. And then this is our m. That 0 is our m. So you could do 0 times 4 plus b equals, and our y value is 5. But if it's a y equals equation and we know the slope is 0, that means every output for x is going to be a certain y value. That y value is already shown. So it's going to be 5. Sorry, guys, my allergies are killing me today. And again, this would be 0. So 5 equals 0 plus b. So b equals 5. If you wanted to do the way that we were doing it for our other style when it's not a horizontal or vertical line. But if you can get Hooy-Vox down, and as soon as you see undefined or slope of 0, vertical, horizontal, x equals and y equals, and get them all straightened out and in their little home in your head, it'll save you some long math stuff, long math work. All right, through a point with a given slope. Now, these are going to be very similar to our parallel and perpendicular that are coming up today in your work. It's the same process. The only thing you have to remember is that parallel lines have the same slope, perpendiculars have opposite reciprocal, which we'll get to in a minute. But this process is the exact same as what you would do for your parallel and perpendicular lines. All right, so I'm going to label everything x, y, m, and we're going to plug it into y equals mx plus b. So y equals mx plus b. So the only thing we're missing is our b value. So our y was a -5. Our m is a -3/2. Don't panic yet. Hopefully it's going to take care of itself. Times 2, and then we're just going to solve. Now, -3/2 times 2. Remember, any whole number has an imaginary 1 underneath it, and every time you multiply fractions, you're working straight across the top, straight across the bottom. What is a -3 times 2? Yes, -6. And then 2 times 1 is going to give us 2. And then -6 divided by 2 is going to give us a -3. So just like our regular equations, this is our great divide. We're going to try to get b by itself. We have that -3. How are we going to move that -3 to the other side? Yep, so we're going to add 3, add 3. If I owe you $5 and then I pay you 3 because that plus sign, then that means I do what? Do I owe you 2? Do I have 7? Yep. I still owe you 2. Perfect. Now we're not done yet. We need our slope and our y-intercept to write the equation. So the equation in slope-intercept form is y equals -3/2x minus 2. Now we've answered the question, number 7's question. If you'd stopped at -2, you wouldn't have done all of the work. So this is our answer. All right, I'm going to skip number 8 because we're going to do the same thing in the next couple. And that double 5, I don't know that it's going to help us stay in line. So we're skipping number 8. Just as a review, we're going to do number 9 or number 10, at least one of them, because those are the ones you did in the puzzle you guys had, the Google puzzle. So in the event you're struggling there, this is what you would go back and do. So the two things you need is slope and y-intercept. And we're going to put it in y equals mx plus b form when we're done. So in this case, usually you don't have the slope, and you might have the y-intercept, depending. But let's pretend like we have neither right now. The red flag, or the yay, is when x is 0, that number is your y-intercept. So our y-intercept is a -2. Because x is 0, that is -2 is our y-intercept, because that means we did not go left and right. We just went straight up to or down to -2, drew a dot, and now we have to count it. As I said before, you can also, if this is calculator active, go put these two coordinates in Desmos and count it to get your slope. But I highly recommend stacking them. So -5, -4, so that's my first coordinate. 0, -2 is my second coordinate. We're going to subtract straight down. Subtract straight down. So -5 minus 0 is going to give me a -5. -4 minus a -2. That minus turns this into a plus. So it's going to be a -2. Y goes on top because he's tall and skinny and can't fit underneath that trampoline. So -2 over -5. But two negatives are going to become a positive. So our slope is 2 over 5. Now, if you notice that this is a y-intercept, then you can boogie from here and write your equation. If you did not notice, then we would keep working, and you could pick either coordinate you wanted. I like the idea of 0, multiplying by 0. We can do the other one if you'd like, just to make it a little, I guess, messier. So we'll call this x, this y, and then we have our m. So our y is going to be -4. Our x is going to be -5. Our slope is 2 over 5. And then we're going to solve for b. So again, 2 over 5, when we're multiplying fractions, let's see if I'm still, yep. 2 over 5 times a -5, which is over 1. What is that going to be? 2 over 5 times a -5 over 1. Remember, you work straight across the top, you work straight across the bottom. And we want it in its most simplified form. Good. So -10 divided by 5, because -5 times 2 is a -10, 5 times 1 is 5, and that's going to give me a -2 plus b equals a -4. We want to get b by itself. That -2 needs to cross over to the other side, so we're going to add it to use its inverse to get rid of it on the side with the b. And b equals -2, which we already knew, but now we have the y. So y equals, our slope is 2 over 5, x minus 2, because of our y-intercept being a -2. So the only added step is the solving for slope relative to the one we just did before. You have to stack them, subtract them, y goes on top. Stack them, subtract them, y goes on top. And I highly recommend doing it that way, even if you learn another way, just because, again, I've watched you guys get really good at them, and then we start switching up letters or putting the wrong thing in the wrong order or using one coordinate for the first y but the other coordinate for the first x. And when you do y2 minus y1 over x2 minus x1, it does matter the order. Like, very much matters. So again, number 10, first thing we need to do, this time we definitely don't have a y-intercept because there's no x. That's 0. So we need our slope. We need our y-intercept. And then we're going to put it in y equals mx plus b form. So slope, we're going to stack them. First coordinate, second coordinate, subtract them. So 5 minus 4 is going to give me a 1, positive. I have 5, I spent 4. I have 3, but I have minus, which is going to turn this into a plus. So that's going to be 5. Y is my second coordinate, or second letter in the coordinate, or second term in the coordinate. So it's going to go on top. So 5 over 1 is going to be our slope. You can pick either point, 5, 3, or 4, -2, to plug in y equals mx plus b. You should get the exact same answer. So if you don't do the one I do, that's okay. But you should get the same final answer for your b value. So if I have x and y, so y is going to be 3. Our slope is 5 over 1. We're going to call that just 5 because that means just whole number 5. And we're going to multiply that times 5. And that's going to be plus b. And 5 times 5 is going to give me what? Yep, 25 plus b. We need to get b by itself. We have a positive 25. We need it on the other side, so we're going to subtract 25. And that's going to give us a -22 equals b. Again, We're not done. It feels like we did a lot of math, but not quite finished. So it's going to be y equals, our slope is 5, and then our y-intercept is a negative 22, so minus 22. All right, getting on to the fun part. Good stuff, okay? Same exact principle. The only thing you have to remember, parallel lines, same. And I guess I should ask you, what is a parallel line? Like, what does parallel lines mean? If I call them parallel lines, what do you know about them? Yes, good. They go in the same direction. They never touch. The notation is two lines like this. So two lines that never touch. They're going to go in exactly in the same direction. Usually their y-intercepts are just different. They're just slid up or down from each other, or left and right a little bit too. But parallel lines are going to continue. They look exactly the same, but they never touch. So just their placement on the graph is different. So parallel lines, you want to think same. And this is considered the slope. So normally, most students, when I say parallel lines, they think either this notation or they think never touch is the first thing they think. What I would love it is if we could get our brains that as soon as we hear the word or read the word parallel, we start thinking same slope, same slope, same slope. Parallel line, same slope. So they both same slope, so two S's, two L's, two lines. Two lines and the two L's in the word parallel, same slope. Okay, so that means if I have an equation here, what is the slope of that equation that's given? So what is your m value for that equation that's given? So in the equation y equals 5 over 4x, what's the slope? Good. Awesome. So 5 over 4. That's what we have to identify first. So we need slope and we need y-intercept to write the equation every time. So slope is the easiest, especially if it's given in slope-intercept form, like y equals mx plus b. Just for conversation's sake, what is the y-intercept for y equals 5 over 4x? So what's my b value in that equation? So there's nothing there, so it's like plus 0. So that 0 is going to be your y-intercept. Not important to write in this next equation, but very important that you can think it. So the more you practice, the better. So we got our slope. Parallel lines have the same slope, so we are going to use 5 over 4, and then we have a coordinate. So we're going to go to our y equals mx plus b. We have our x value. We have our y value, and then we have our slope. Just getting negative 1. Our slope is 5 over 4. And then our x value is a negative 5. Wow, this one's going to be ugly. And we need our y-intercept. We need our y-intercept. All right, so negative 1 equals 5 over 4 times a negative 5. So 5 over 4 times a negative 5. That's going to be 5 over 4 times a negative 5 over 1. 5 times a negative 5 is going to give me negative 25 over 4 plus b equals a negative 1. 4 does not go into 25 nice and neatly. 4 does go into 24 quite neatly, and that's going to be 6. So we know we have a negative 6 and 1/4. And 1/4 is the same. If you think about $1, 1/4 is going to be 25 cents. So I'm going to change that 1/4 to 0.25. And then we may go back and switch it back when we write our final equation. So 0.25 plus b equals negative 1. I need b by itself. That negative 6.25 it's going to become a positive 6.25. If I have $6.25 and then I take one away, how much money do you have at that point? You have $6.25. You lose $1. How much money do you have at that point? Yes. Let's be 5.25 equals B. So we have our slope up here in rise over run form, which is perfect. And we have our y-intercept of 5.25. So it's going to be y equals 5 over 4x plus 5.25. And that could be written 5 over 5 and 1/4 as a mixed number. Very rarely have I seen it that way. It could be 21 over 4, because 5 times 4 is 20, and then it's 1/4 more. So that could make it, if you should find the y-intercept to be a fraction, it could also look like that. All right. Parallel has what kind of slope? Lines parallel has what kind of slope? Parallel has what kind of slope? In this case, it is going to be negative 7/3 for this equation. Yep. But it's going to be same. And that's just me trying to get you to remember that word. So as soon as you see the word parallel, we want to think same slope. So we're going to look at that negative 7/3. So we're going to use a negative 7/3. Now, hear me out. That plus 5 means nothing to the new equation. Absolutely nothing. The y, the x, the plus 5, all of it, just fluff as far as writing the equation that is parallel to this line. The only thing that you need, and if that means you need to go through and scratch all this mess out, do it. Because for whatever reason, we get a little overwhelmed with all that extra goodies, and all you need is the slope from the line parallel. So again, we're going to go grab our point 3 and 4, and so we're going to have x and y. And then we're going to plug it into y equals mx plus b. So our y equals our slope. This one's going to be a lot nicer than the last one. Negative 7/3 times our x value equals and then plus b. All right, negative 7/3 times 3. So negative 7/3 times 3/1. Negative 7 times 3 gives me what? Yep, and then we're going to divide that negative 21 by 3, and so our slope, that value, slope times x, is going to be what? Negative 21 divided by 3 will give me, good, a negative 7. So negative 4 equals negative 7 plus b. We want b by itself. We're going to move that negative 7 over by doing the inverse. So we're going to add. So if I owe you $4 and I paid you $7, that means you have made $3 off of me. Positive 3. Now I have my y-intercept and I have my slope. So I'm going to write my equation. Y equals negative 7/3 x plus 3, our y-intercept, or b. Now this line is a negative line, so it would be decreasing. So as the x values increase, so as I look to the right, the y values are going to decrease are going to decrease. So increase, decrease is the relationship. So as I look to the right, the line should be going down. So it should look something like this. And it would cross the y-axis at a positive 3. All right, so parallel lines have what kind of slope? What's the magic word we want to think? As soon as we think parallel lines, we want to think blank slope. Yes, same slope. Parallel lines, same slope. Now, perpendicular lines. Hold on to your britches. This one gets fun. So perpendicular lines. First of all, what does perpendicular mean? Do you remember? What does perpendicular mean? Oh, good. Opposite, reciprocal, opposite. Good. The word perpendicular means, though, this is your notation for perpendicular. It means lines that intersect or cross at 90 degrees. So 90 degrees is what you want to think about these lines. So that perpendicular, that little box. And a lot of you guys, students in the past, have known what it meant, but to put it in words is fairly difficult. Okay? So good guess on the opposite part, and reciprocal is awesome. Perpendicular lines have opposite reciprocal slopes. So 2 parts. So opposite, which means if it was positive, it's going to become negative. And then reciprocal is the math word for it, but I like to call it flip. So opposite, and then we're going to flip our fraction. If it's a whole number, remember it's sitting over an imaginary 1, so we can still flip it. So opposite reciprocal. So just for a side note, if I had the fraction, let's see if I can get a piece of paper, there we go. If I had the fraction 1/2, what's the opposite of a positive 1/2? Negative 1/2. So that took care of the opposite part. And then what is the reciprocal of a negative 1/2? So we want to flip it over. Yep, negative 2 over 1. And if we're being honest, that's going to become a negative 2. All right, so if I have a negative 3 over 4, what's the opposite of negative 3 over 4? Yep, positive 3 over 4. So we took care of the opposite, check. And now we have to do reciprocal. So it's going to turn into a positive 4 over 3. Good. And let's see, one more. Let's do positive 3. What's the opposite of positive 3? Negative 3. Good. And then we want to take its reciprocal, so we want to flip it. Remember, this is sitting over that imaginary 1. So it's going to become a negative 1/3. So we have 2 steps always. Not just opposite, not just reciprocal. It has to be opposite and reciprocal. All right, so getting on to perpendicular lines. So the first one, we want to look at the equation given. The only thing we need to pay attention to is the slope. What is the slope in this equation? What is the slope in the equation given? Negative 1/3. Perfect. So we have negative 1/3. This says perpendicular, though, so we're not going to use that negative 1/3. We're going to take its opposite and its reciprocal. So if I found its opposite and then I flipped it, what slope am I going to use for this equation, the new equation I'm writing? Yeah, positive 3 over 1, or 3. So what I like to do, because it gets to be a lot, is either have a chart on the side that says slope I use, or I go highlight what's important. So I know I'm going to need that when I'm done in my final equation. So now I have my x, and I have my y, and we're going to do just like before. So y equals m times our x value, and then plus b. So we have 2 equals 3 times a negative 1 plus b. So 2 equals, that's going to give us a negative 3 plus b. We want to get that b by itself. So we're going to add 3 to both sides. And b is going to equal 5. Now, again, if you're highlighting or you're willing to highlight and go through all of that good fun stuff, I would highlight this too because that's important. Now we have to write the equation parallel to y equals negative 1/3 x minus 4. Y equals positive 3x because it's the opposite reciprocal plus 5 because that's the new y-intercept. And y equals 3x plus 5 is perpendicular to y equals negative 1/3 x minus 4. But again, pay attention to that negative 4. We didn't use it for anything. We didn't use the x. We didn't use the y. We took the slope out. We flipped it and made it opposite, and then we used the opposite reciprocal because this is perpendicular. All right, so number 14. What's the slope in the y equals 1/6 x minus 5? What is the slope as given in that equation? 1/6. Good. Now, it says perpendicular, so we're not ready to rock and roll yet. We have to do the opposite and the reciprocal. What is the opposite reciprocal of 1/6? It's positive, so now it's going to become, yes, negative 6 over 1, or like you said, negative 6. So now I have my slope that I need to use because this is perpendicular. Had this been parallel, we would have used 1/6 because that means my rise and run would be exactly the same and they could never touch, which is the definition of parallel. I'm going to take my x and I'm going to take my y. I'm going to plug it in. So y equals mx plus b. So negative 6 times a negative 1. So a negative and a negative gives me a what? Positive 6. Good. Don't mind my b's and my 6's. They look very, very similar. I try very hard to keep them from looking alike, and they look alike anyway. I do need to move that positive 6. So I'm going to subtract it from both sides to get it over those equal marks, or cross the great divide, as I always say. Now, if you have $2 and you spend 6, what are you going to be sitting with then? So 2 minus 6 means you're going to have what as the final of that? Good, negative 4. So now we have our y-intercept. And now we can write our equation. So y equals negative 6, because I highlighted it so it's easy to see, x, because that's my new m, minus 4, because that's our y-intercept we just solved for. And the equation y equals negative 6x minus 4 is perpendicular to y equals 1/6x minus 5. And you know that because the slopes are opposite and reciprocals. And that's all you're going to work on today is parallel and perpendicular lines. The math process is exactly the same as the ones you've been practicing before, except you have to stop and do opposite reciprocal or same slope. So as we're wrapping up, if they're parallel lines, what kind of slope do they have? Good, same slope. If they're perpendicular lines, they have what kind of slope in comparison to the other one? To the line that it is perpendicular to. Opposite and, yep, flip. So it's got to be opposite and flip. So if it was positive, it becomes negative. If it was negative, it becomes positive. And then the fraction flips over. If it's a whole number, we turn it into a fraction. Otherwise, that should be it, guys.